Hello everyone, this is Karthika from the Department of Biomedical Engineering. Today we are going to discuss about biomedical image fundamentals. First one, what do you mean by digital image processing? Here it shows a sample digital image which contains 662 cross 640 cross 256 pixel size, and in this sample image it shows the x and y components of a image. Normally the image taken from a natural source, or it can be any medical or any images from outside we can take. And we know that x and y, it denotes the function of f of x comma y. It denotes a two-dimensional function where x and y are spatial coordinates, and the amplitudes of f at any pair of coordinates x, y is called intensity or gray level of the image at that point. Here the x size is 662, y size is 640, and the gray level is 256. Normally gray level it measures from 0 to 255. Here the digital image x, y and the amplitude values of f are all finite. It means all are discrete quantities. It is measurable. And the next one, here it shows a sample color image in this 800 cross 600 cross 24 bits. It indicates the pixel size in XY components. And the next one is, what do you mean by pixel? What is pixel? What is pixel in an image? Pixel is nothing but the elements of a digital image. It is called a pixel. In this example image, the dotted lines, the dotted lines and the blood lines, the blood dots, it indicates the elements of a particular image. Each and every element is highlighted in the pixel. And normally digital image, it is used in many applications. Here mainly it is used for searching faces, license plate identification and tracking people. For that we are using digital image. And the origins of a digital image processing, one of the first application is in the newspaper industry, when pictures were sent by submarine cable between London and New York. This is the first application of a digital image processing. Here this sample picture, it shows the digital picture produced in 1921 from a coded tab on a telegraph printer with the special type faces. This is the first application of a digital image processing. And the second one is to obtaining a better quality. The image is modified, and the sample image, it shows the digital picture made in 1922 from a tab punched after the signals had crossed the Atlantic twice. Here some errors are visible. These errors can be rectified in the future. And the next one is another sample image, 15-ton equipment. It is a unretouched cable picture of generals Pershing and Foch. It is transmitted in 1929 from London to New York by 15-ton equipment to improve the quality of the image. And after that we are using computers. From this, the meaningful image processing task can be appeared. Here this sample picture, it shows the first picture of the moon by US spacecraft. We know that very well. And the next one is we are using digital image mainly for medical imaging, remote earth resource observations, astronomy, high energy plasmos and electron microscopy. And here examples of fields that use digital image processing. Here this diagram, this picture, it indicates electromagnetic energy spectrum. This spectrum, it contains gamma rays, X-rays, ultraviolet, visible, infrared, microwaves and radio waves. Here the electromagnetic spectrum is arranged according to the energy per photon. Here the energies of one photon, it is measured in electron volts. Next one is here we have listed some of the applications of digital image processing. Here the one is gamma ray imaging. Here it shows the example of a gamma ray imaging. First one is a bone scan, second one is a PET image, third one is it is a Cygnus loop, and fourth one is gamma radiation, bright spot from a reactor wall, and also those images are taken from a GE Medical Systems, and based on the digital image processing, we can differentiate the images based on their intensity, based on their color, based on their contrast. Depending upon the applications, we can segregate the images by using digital image processing techniques. Okay, next one is X-ray imaging. This shows the example of X-ray imaging, chest X-ray, and we have a head CT and aortic angiogram. Like that, we are shown some examples for digital image processing in biomedical field, because this is how digital image, how image processing evolves biomedical images. So here we have shown some medical applications. And next one is imaging in the ultraviolet band. Here it shows the examples of ultraviolet imaging. First one is normal cone, and this SMAT cone, and Cygnus loop, and also these images, they are using UV rays to we are using UV rays to enhance the images based on the biomedical applications. Next one is imaging in visible and infrared bands. This shows the examples of light microscopy images. Next one is how digital image used in remote sensing. First one is visible blue. We know that the wavelength of visible blue in micrometer is 0.45 to 0.52. The characteristics is maximum water penetration. So it is normally used in water penetration applications like that. And the next one is in remote sensing. We have several types. First one is visible blue, visible green, visible red, near infrared, middle infrared, thermal infrared, and middle infrared with different wavelength. Here, this can be used for maximum water penetration, and visible green, it is used for measuring plant vigor and vegetation discrimination, biomass and moisture content and solid of vegetation. And also we have wavelengths, we have certain characteristics to measure the mineral mapping also. It shows thus it can be determined, it can be calculated from thematic bands in NASA's Landsat satellite. Landsat is nothing but it acquire and it calculate, it analyze the information based on the land's behavior. And the next one is the example. It shows Landsat satellite images of Washington. This image, it shows weather observation, visible and infrared bands. Here in this figure, satellite image of Hurricane Katrina taken on August 29, 2005 using Landsat. This is one of the major applications of a Landsat. And then this shows the infrared imaging, which comes under digital image processing applications. Next one is here the image, it shows the infrared satellite images of a remaining populated part of the world. The small green map is provided for reference. Next one is automated visual inspection. Here are some examples of manufactured goods often checked using digital image processing. Okay, first one, picture A, it shows the circuit board controller, and then picture B, here it shows the packaged pills, and third one is bottles, fourth one is bubbles in clear plastic product, and then next one is a sterile, fourth one is image of a intraocular implant. Next one is some of the additional applications of imaging in visual spectrum. Here first one is thumbprint, second one is a paper currency, and a third and fourth one it is for automated license plate reading. Next one is imaging in microwave band. Here the space-borne radar images of mountains in southeast Tibet. And then imaging in the radio band, we can use MRI imaging in radio band. It shows the figure. It shows the MRI images of a human knee and spine. And also we have several types of imaging. Here I have listed only 5. First one is gamma, second one is X-ray, third one is optical, fourth one is infrared, and the fifth one is radio. And next it shows the examples in which other imaging modalities are used. First one is a sound. Here the cross-sectional image of a seismic model is shown here. The arrow points in a hydrocarbon, oil or gas trap is shown here. Next one is ultrasound. Here it shows the ultrasound images examples. First one is a baby, and the second one is another view of a baby. Third one is thyroids, and then fourth one it shows the muscle layers shown in lesion. Then electron microscope. Next one is images generated by computers. Here, the fundamental steps in digital image processing. Here we have methods whose input and output are images. The methods whose outputs are attributes which are extracted from those input images. In this figure, it shows the fundamental steps in digital image processing. First one is we have a problem domain. In this, we have image acquisition. The image is enhanced, image restoration, and then color image processing. After that, have to improve the efficiency of the image. We have wavelets and multi-resolution processing. We have compression, morphological operations, segmentation, representation and description, and finally we have object recognition for a better results. And in image operations, we have local averaging using neighborhood processing. The procedure is illustrated in the images A and B. Okay, and the result is shown here. This result, it indicates the images of a size 790 cross 686 pixels. And also we have spatial filtering applications in digital image processing. First one, it shows the blurred image of the north pole of a moon, and then the second one, it shows the Laplacian without scaling, and third one is Laplacian with scaling. And then the last one, and the D and E, it shows the image sharpened using mask, and then the result of using mask. Here the final result, it shows the clear image of a moon. And then we are using filtering in digital image processing also. Here the filtering in the frequency domain, how it works are explained here, are shown here. And then final image restoration. Here the satellite image of a Florida and the Gulf of Mexico showing horizontal scan lines. And then it shows the spectrum also. And then here we are using a notch pass filter. It is superimposed on, and the final result we have in spatial noise pattern. And then final one is about the result of the notch rejectant filtering. And then we are using color image processing for making our image more efficient and effective. Here we have for color image processing, we use chromaticity diagram here. And then components of a digital image processing, we have first we have a component network. In this we have image, first one we have image sensors to acquire or to get the image, and then we have specialized image processing hardwares and image processing softwares. In this hardware and software, it is interlinked with the computer and the mass storage device, and the output we have either image displays or hard copy, which are linked with the network components. Here this diagram, it shows the components of a general purpose image processing system. That's it. Thank you.